Okay, so we're going to work some examples, talk about polar and Cartesian coordinates. All right. And these three formulas are key for our success today. The first one's just from Pythagorean theorem, and then the second ones are from SOHCAHTOA. Because if you look at it, for instance, if we said, hey, what's the cosine of my angle? I would look at this reference angle. I'd say cosine is adjacent over hypotenuse. So cosine of theta equaling x over r. I can multiply both sides by r and get x equals r cosine theta. So that's kind of how that is derived from your SOHCAHTOA and your right triangle trick. All right, now we're going to practice using these formulas. Okay. Oh, Andrew?
You scroll up. The hypotenuse, is that a square root or an
R? That's R. Just a crappy looking R. Yeah, so R stands for radius. And really, if you think about it, I'll go ahead and let the cat out of the bag. You guys have you've got a delta math on this. It's super easy. Oh my goodness, it's so easy. All right, so like watch this. Oh, wow, look at that. Michael Davis, that a boy. Do you agree that these are like super easy? Okay, so like this is an example. You're looking at what's called the pole. Did we talk about the globe in here? Yeah. All right, so I'm looking down at the globe. There's the pole. There are those lines of latitude. And so really for this one, okay, it's 2 pi over 3, which is 120 degrees. And so I'm going to drag that to 120 degrees, and it's going to be 2 units away from the origin. And that's literally all I've got to do in this polar. And look, I love how they've got the drawing there at the angle, and then they go 1, 2 away from the origin. It's super duper easy. Okay. Now, that being said, here I'm given 6, 120, and I could definitely graph this out. I know it's in which quadrant. It's in quadrant 2, and it would be 6 away from the pole. All right. So 120 degrees right there. 6 is my R. 120 is my theta. What does that mean then that I would find for x? X is going to be 6 cosine of 120. And what's y going to equal? 6 sine of 120. Now, you guys have practiced with me on your most recent quizzes, on your most recent homeworks, assessing, okay, well, what is the cosine of 120? So for cosine of 120, what I would recommend doing is I would just think about it like, oh, that's a 60-degree reference angle. We got 1, 2, radical 3. BJ, why is the 1 negative? Very good. We move to the left. We know cosine is adjacent over hypotenuse. So this cosine of 120 will be negative 1/2. 6 times negative 1/2 equals negative 3. And then the sine of 120 would be radical 3 over 2. 6 times radical 3 over 2 would be what? 3 radical 3? So my R and my theta here would be 6 120. That's R theta. That's what was given to us. And my x, y, which we just calculated, would be negative 3 radical 3. And that makes sense, too, because if the radius is 6, that means I'm multiplying everything by that scale factor of 3. And that gets me there to that spot. 3 radical 3 is my y value. Negative 3 is my x value as we move. As BJ said, we moved to the left. Easy enough? All right. So go to our next example. We got 10, negative 220. Alfredo, help me with my location. Which quadrant is negative 220 going to be in? Try again. It's negative, so we're gonna work around in the clockwise direction. Very nice. Quadrant 2, right? Because we're going to swing around here past negative 90, past negative 180. How far past negative 180? 40 degrees. Okay, so that smells like a calculator question because 40 is not a what? Not a special triangle. We don't have a 40, 50, 90 degree triangle. Okay, so if I'm at 10 away, and this is, I'm just a creature of habit. So 220, what is that going to be? 140 in standard position? Yeah. 140 degrees in standard position. And so I'm going to say, well, x equals 10 cosine 140. And y equals 10 sine 140. Freddie, help me out. What is the relationship between the angle that they gave us, negative 220, that I asked Fredo about, and the angle 140 that I plugged into my formula? What's the relationship between those angles? The C word. Not coplanar, coterminal. Good. So they're off fill by a factor of how much? It's backhanded, Michael. Now, what are they off by a factor of? 360 degrees. Good. And anytime I've got an angle that's like too low, too negative, we can raise it up by adding 360. What if, Eli, what if this was like a big old fat daddy angle, like 1,000 and something? What could I do? Yeah, we could bring it down. We could subtract multiples of 360 till we get it to a manageable number. And I said this is a calculator question. What mode should my calculator be in? All right, I should definitely be in degree mode. So we're going to go 10 times the cosine of 140. You get about negative 7.66. What's up? Correct. Yeah, you could just, so like you could do 10 sine 140, and you can get 6.42 thereabouts. Good question. Easy enough. Polar and Cartesian kind of swippity swap. Correct. So good. You may have heard me say I'm a creature of habit, and I kind of habitually, I like to do things in terms of degrees. I like to do things in terms of 0 to 360. Bless you. So like any time you're given an angle like this, negative 220 legit would work because they're all coterminal angles, and all these coterminal angles are going to produce the same trig ratios. I am just a person who likes to have things kind of neat and pretty, so to speak, between 0 and 360. All right, Mario?
This quiz we answer with what are the
No, so we would probably in this case, since it's, as Franklin astutely observed, this is not a special angle. So I would expect you around to, like, I don't know, the 10th place or the 100th place, something like that. And I would tell you in the instructions. All right, let's try one for you guys to do. And the twist here is this one's in terms of what? It's not in terms of laptop, Kenneth. So you can put that away. Boom! Roasted. You too, BJ. Can you finish what? Oh my goodness, Kenneth, is that what you're doing too?
No.
You're doing your service hour? Checking your service hour. He's not even submitting. He's checking.
No, I was gonna.
Mhm. Oh, you're gonna submit all right.
No.
Pause. Y'all are so bad. Do it. Hurry up, BJ. Sure. Your shirt tail's way out. You okay? Hang in there. Denegri, what is 11/5/6? Oh my goodness. What? I'm a degree man. What kind of degree angle measure is 11/5/6? Attaboy. That's what I shoot for. 330 degrees. Henry is in which quadrant? Fourth quadrant. Hey, by the way, do y'all notice that I'm drawing each and every single one of these? Right? That is a great habit to get into. All right, so 330 degrees. So I got x is going to be 9 times the cosine. 330. Now let me think about 330. That's going to be -1, a 2, and a radical 3. So cosine is 9 radical 3 over 2. This goes to Mario's question, the last one. I should give this as an exact value because it's special angle. And I can use special triangles, easy peasy. Y is going to be 9 times the sine of 330. Sine will be -1/2. So -9/2. And if we want to put that in ordered pair, I'm fine with that. Please refrain from the dirty decimal unless they ask you to round. We had a great experience Monday afternoon, Mr. Teddy and I went on a hike. We've been training for Philmont, and we had a heavy backpacks on, about 45, 50-pound backpacks. And so Betsy was doing the tennis practice, and Teddy and I hiked around Arlington, and we stopped at the Sonic. You guys ever go to the Sonic? We got a little treat. We hiked. It was a 4-mile hike, and so we hoofed it and got to the Sonic and got a blue raspberry cream slush. Okay, got a large one because we were sharing, and it was delightful. But it was $9 deadgum dollars.
$9.
It was, yes, it was $9. That was a big old cup of goodness, but still $9 I felt like was a lot. I don't know if y'all have experienced the inflation these days, but that certainly hit home. All right, last one. We want to try this on our own again. I'll tell you, there's a little dip, little drive here.
You have a negative.
Oh, that's the curve. We're gonna talk about that and see if you can figure it out. Trust the formulas. Trust the formulas. And keep in mind, what was I doing at the beginning of every problem? Drawing. Good, drawing it out. As I walk around and see it's a good looking drawing on most people's papers. Yeah, totally. Oh, sweet sassy molassie. Oh, this is gross. Y'all want to see this? Something just fell out of my ear. That just looked like a piece of more time.
Yeah. Whiz. Yeah.
That is your way.
Negative mark. But if you trust the if you trust the formula and your drawing, it should, those two, you should be able to reconcile the two.
I got it.
Y'all ever have that happen to you? When you're flying, do your ears ever mess up?
Yeah.
My ears don't.
Ugh. Do what?
Mine don't unpop after like a day or two.
Okay, let's see here. Stephen, I don't know if I've hit you up yet. Tell me about my quadrant. This is a negative 5 pi over 4. What quadrant is that? Very good. Second quadrant. Excellent. Because as Fredo and I were talking about a second ago, negative angles rotate in which direction? Clockwise. Now, 5 pi over 4, that's a bar plus 2 plates on each side. So that's 225. All right. So it's negative 225 in the second quadrant. Now, I am the kind of fellow that would say, oh, okay, well, that's a $1.35. You know, that's my quadrantal angle right there. So I know that this is going to be a 45, 45, 90. And so we're going to have 1, negative 1, and radical 2. And I told you guys to trust the what? Trust the formulas. Okay, so x equals r cosine of theta. What did I say theta was? 135. And y equals r sine 135. Now, let's think about this. I got my picture drawn up. I got 135 located. Cosine's adjacent over hypotenuse, negative 1 over radical 2. Okay, so the negative times negative is going to be positive 5 over radical 2. And then sine would just be 1 over radical 2, so negative 5 over radical 2. Now, what do you know? This is where we're going to kind of do a little bit of learning on the job here. What do you know about a positive x value and a negative y value? It's in which quadrant? Positive x, that means I'm moving to the right. Negative y, I'm moving down. Oh. Now, here's where a little bit of some learning takes place. It is going to be 180 degrees in the opposite direction. And you might jot down that a negative r value does that. A negative R value, and you'll see this fleshed out on the homework. A negative R value means that I am 180 degrees in the opposite direction. So the actual location of this point in rectangular coordinates is 5 radical 2 over 2 if we wanted to rationalize, and negative 5 radical 2 over 2. Those are its x and y coordinates. And another polar coordinate that would be in the same location would be positive 5 and 7 pi over 4, or positive 5, negative pi over 4. All three of these, this is Cartesian, this is polar, this is polar. All three of these are in the same location. And actually, if you wanted to even include the whole kit and caboodle here, all four of these describe the same location. All four of those ordered pairs describe the same location. Okay? Polar coordinates do not have unique representations because there's infinitely many angles that could describe a particular location, right? With Cartesian coordinates, there's only one answer. There's only one way to describe where you're at here, and it's this far to the right, this far down. But with polar coordinates, we could describe it multiple ways based on the fact that there's infinitely many coterminal angles, and you can have a positive R value in the proper direction or a negative R value in 180 degrees of the opposite direction. So a negative R value means turn around, go the other direction. Ken?
Why did you give it 45? Like, what was that your?
Well, I forget who I asked. Was it Stephen? I think it was Stephen. Stephen properly identified this as negative 225 degrees, which we said would be right there, in that second quadrant. But because of the negative R value, that told us, hey, you got to go 180 degrees in the opposite direction to get to the actual location that's describing. Yes.
So if it's negative, why wouldn't you go wouldn't you go counterclockwise?
Incorrect. Negative means we go clockwise.
I mean, yeah, clockwise, and then.
So we went so 5 pi over 4, and Franklin, I'll get you, and Stephen, you too. 5 pi over 4. If we times that by 180 over pi, the old school way of canceling things out, 4 goes into that 45 times. 5 times 45 is 225. So negative 5 pi over 4 is negative 225. All right, and negative 225, you can't see the negative anymore. Negative 225 was where we said, hey, you're going to go around in the clockwise direction. You'll land in the second quadrant. And then we said, well, hey, because there's that negative R value from the second quadrant, I want you to swing around in the opposite direction, 180 degrees in the opposite direction. All right, so Franklin? The reference angles? 100%. Yeah. And anytime you got a pi over 6, your reference angle is going to be 30. Steven. No, because the actual location, this green triangle that I drew up here, let me get rid of it. Because the green triangle was just a construct to sort of help me figure out what my formulas were going to be. The actual location of this point, there's only one location, and it's right here at this red dot. And you think about that red dot means we went 5 radical 2 over 2 to the right, 5 radical 2 over 2 to the in the downward direction. Okay.
So is the first polar pair that you wrote up, is that it going counterclockwise and the second one going clockwise?
No, good question. Right. So this first one, well, actually, maybe you said it. I think my ears are playing tricks. I mean, did you say counterclockwise and clockwise?
Yeah.
Yes, sir. Then what you said is correct. So this one, 7 pi 4, we go woo all the way around to the third quadrant. This one, we just went, just 45 degrees to the down into the fourth quadrant. It's the same location either way.
Actually, it's getting kind of hard to see what R is, I guess. I can't envision it.
All right, so R is going to be your distance away from the pole. So R, in this case, would be 5. All right, if you were up here and you were talking about that location, it would be negative 5. So this will be instructive to go back to the delta math, okay, and to look at the rectangular to, no, we want polar to rectangular, and to look at some of these, and I'm going to hit new problem until we get a negative. They give you any negatives? Why aren't they giving you negatives?
I think the second.
There you go.
The second one has some negatives. Ah, okay.
Got it.
Booyah. There we go. Okay, so this will be a good one to look at. So first of all, where's negative pi? Does anybody know? Straight to the left. No. Negative pi is going to be 180 degrees in the counterclockwise direction. Now, negative 2, I'm going to go yoink. I'm going to go back over to the right, 180 degrees in the opposite direction. So this one is going to be located here. And now here's where I like their explanation, okay? So watch their explanation. Watch. You ready? So we swing it around, okay? And then we move 180 degrees in the opposite direction because of the negative r value. Let's look at another one. Yes, sir. When you say putting it in the first one, I don't know what that means. Oh, okay. So like whatever R is, if R is 2, we're gonna go, there's 1, there's 2, there's 3, there's 4. So like the farther out you go, would be your R values. So like an R value of 2 is gonna be oops. Okay, so like if I wanted to pretend like this R value right here was 8. Right? 3 pi over 2, so I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. There's where I would be if that were 8. Now, what if that were negative 8? Where would I be? I'd be up at the tippity top right there. So that would be negative 8, 3 pi over 2. This would be positive 8, 3 pi over 2. This would be positive 8 pi over 2. You get what I'm saying? So there's like infinitely many ways that we could describe each of these kinds of points. So like down here, we could say, well, this is negative 8 pi over 2. You get what I'm saying? So like I always consider, okay, angle first. Where's the angle? 90 degrees, boom. And then, oh, we got a negative, then I'll come down here. All right. So that's how the negative R value will work for these. Real good question there. Whoever asked that, I've heard by Blake, I think. Finley, what you got?
Can you go back to
Delta man? Lesson notes. Okay.
I think you get to the 5 and 2,
Okay, so that is a question of, do I know how to evaluate cosine of 135? So 135 degrees, second quadrant bisects it. That's a 45-degree reference angle. So we have a 1, 1, radical 2. And then cosine is adjacent over hypotenuse. So that's, we had negative 5 times negative 1 over radical 2. And so that negative times the negative canceled out and gave us this positive result right there. Good question, Finley. All right. Oh, look, Kenneth's laptop's back open.
How about 35? Good. 30.
That's good.
Very
Very good. Do what?
No, very close.
Hey, I'll tell you what, Teddy got some good service hours this past weekend at the track meet. Do y'all ever do your service hours via track meet?
Nope.
It's a good way to do it. Yeah, that's what we did. So yeah, he went up there and they gave him like a yellow vest. And so he sat with an iPad and registered kids for the shot put. And then when they measured the shot put throw, he would record their time or their distance rather. And so that's how he just literally got like 4.5 or 5 hours of service just doing that. And they give you a free coupon for like a hot dog or hamburger or something like that, which is always nifty. Good stuff. All right. Yeah, Coach Bar. My daughter runs with Memphis Youth Athletics, and so it was a kill two birds with one stone kind of situation. Here's what I want to do. I'm going to end this screencast now that we're done talking about polar coordinates.